All right, so this is what we are building. A user types in a plain English question in the browser. This question gets sent to a Flask app, which is just a simple web server. Flask passes the question to a Gemini 3 agent. The agent looks at the question and it decides which tool to use. We're going to create these two tools and make them available for the agent to use. We've got one tool that allows the agent to access BigQuery in the backend. So if the question is a data question, like about sales numbers or order counts or revenue or something like that, it calls this tool and it writes a SQL query that then queries this orders or products data that's being hosted in BigQuery. And then returns a plain English result based on the results of that query to the user. Similarly, we have a tool that our agent can use to read a document. This is a policy document that we have in cloud storage. And so if the question is about like a return window or refund rules, we can return answers to questions about that as well. So these are tools that we give the agent. These are not available out of the box. And the agent picks the right tool. It gets the result. It writes a human readable answer that goes back to the browser or the user accessing the browser. So by the end of this video, all of this will be running. We're going to build every piece from scratch. And one thing I want to say is that I'm really going to try to give you a true understanding of every step that I take here. You know, I think with a lot of these new technologies, especially things like AI agents, there are a lot of hype of videos out there that give you kind of the feeling and the hype of being able to do cool things. You watch someone else do something, but it doesn't necessarily give you an understanding of what is actually going on. And then at the end, you feel like it's your fault that you're lost when it might not be your fault. So I'm going to try to build this piece by piece and explain every part as we go, including the code that we're going to use. And I hope that gives you an appreciation for what we've done here and like a better understanding of what we've done. All right. So let's talk about when you would actually potentially use something like this. Let's say, for example, that your company has sales data sitting in BigQuery and it's got policy documents either in cloud storage or somewhere else, and you could put them in cloud storage or somewhere else accessible by API. People might keep asking the same kinds of questions internally, right? Like, what are our top selling categories? What are our return policies on different product categories? And every time that someone asks this question, they have to go write a query in BigQuery or access some dashboard or dig through a document. Imagine if instead they could just type a question in plain English and get a real answer from the real data or the real source, just through the same interface, right? Without needing to go to different places. And so that is kind of what an agent like this could do. So it's not like it is allowing you to do something entirely new that you couldn't do before, but it's making it more convenient. It's making it easier to get answers to these questions because of the tools that we're making available to it. Okay, so let's set up our environment. We're going to go to Cloud Shell, and Cloud Shell can basically be opened anytime by going to the Google Cloud Console and clicking this button here. And then you can click the Cloud Shell editor here to get to the view that I currently have up right here. So this is the Cloud Shell editor, and we've got a terminal window down at the bottom as well. Now, first we're going to talk about some of the SDKs that we need to install. So Google recently released a new unified SDK for Gemini called google-genai, and we're going to need to install that. google-genai. We're also going to need to install, actually I'll just copy these over, Google Cloud BigQuery and Google Cloud Storage. So these are the SDKs for generative AI, BigQuery, and Cloud Storage, respectively. And I've already installed these on my Cloud Shell instance, so this will probably take just a couple of seconds. If you haven't installed them yet, it might take a little bit longer. But there we go. Those are installed. Now we need to set certain environment variables. So I need to set, I'll walk through these as well. I need to set the project, and I need to set the location, and I need to tell the GenAI SDK to use Vertex AI. So this is just printing the project and the location. It doesn't look like I've set the project yet, so that means I need to type gcloud config set project and then the project ID. The project ID can be grabbed from the console for your project, just right here. We can copy that and we can bring that over here. And so now the project has been set in my gcloud configuration. You can see that it's being shown in yellow here. And then I can rerun everything that I just copied. I'm just going to copy it in again. So I'm setting all these environment variables. A couple things to notice. The location here is global. So that's because Gemini 3 models need to run on a global endpoint, not a regional one. Additionally, when we tell google-genai to use Vertex AI, the reason we're doing that is because another option is to use the consumer Gemini API. And so the models are the same, but Vertex AI gives you logging, it gives you identity and access management, and it gives you better scalability if you were to want to put this into production, right? Now we need to make sure that the Vertex AI API is enabled in our project. I have already enabled it, so this will just take a second, but it might take a minute for you if you have not enabled it yet. Quick note about this as well is that the API for Vertex AI is aiplatform.googleapis.com. That's because Vertex AI used to be called AI Platform, and they couldn't or didn't want to change the name of the API itself. All right, good. Now let's write some code and ask Gemini a business question with no tools that we're adding to it, no access to any data. So first, I'm going to make a file here. I've created a directory here called agent demo, and that's the one that we're going to be working in. In fact, I need to make sure that in my command line here, I am in agent demo. And so we're going to make a Python file called agent.py, and we are going to ask Gemini a business question with no tools. So what we're doing here, let me just explain each line. From Google import GenAI, that is the new GenAI SDK. We're doing one import for the whole thing. The next line here, client equals GenAI.client. This is just creating a client. It's picking up the project ID that we established in our environment variables. And we don't have to pass them explicitly as a result of that. Down here, we've got the actual API call. We give it a model name. We're using Gemini 3 Flash, and we are sending this prompt as well. We're asking what were the top five product categories by revenue last quarter, and we're going to see what we get back. So down here, we are printing response.txt, which is just the actual text that the model sends back. So let's run this. And let's see what we get. We'll probably get some generic response, honestly, because this is basically the same as if you wrote this question in the Gemini UI, like the Gemini web app. Yep, so to provide an accurate answer, I would need to know which company or market you are referring to. As an AI, I do not have access to your private business data. Exactly right. It doesn't have access to our private business data. So we need to give it access, and that's what we're going to be doing. Now, we are going to use a data set in BigQuery for this. And BigQuery, if you've watched some of my other videos, you know this as well. BigQuery has public data sets that are available for you to kind of play around with, which is pretty cool. And we are going to use one that essentially has data from an e-commerce store. I don't even know if it's a real e-commerce store. I think it is a hypothetical e-commerce store, but it's realistic in terms of the actual tables and data that's in there. It looks very much like the data that you could have if you did run an e-commerce store. We've got multiple tables here. This is the one that we're looking at. The Look e-commerce. I guess that's the name of the company, The Look. And so we've got distribution centers, events, inventory items. We are going to pay attention to order items and products. And so if we wanted to grab the top 5 product categories ourselves, this is the query that we would write. So if we were going to, let's say, try to grab that for the last quarter of 2024, this is the query that would grab that for us. I'm going to walk through it real quick. We're querying 2 tables here, as I said, order items and products. Order items has the individual line items with sales prices. Product has the category for each product as well as other things for each product as well as other things. But we need the category because we want to rank the categories by how much they sold. And I am joining them on product ID so I can group by category. The where clause here filters to the 4th quarter of 2024. That is October 1st through December 31st. We're doing less than January 1st, before January 1st. And I am also excluding canceled and returned orders since those are not real revenue. And then we are grouping by category, and we are also ordering by total revenue in a descending fashion and limiting it to the top 5 because we want the top 5. Okay, so when we run this, all right, we can see the top 5 categories. So we've got outerwear and coats, jeans, sweaters, fashion hoodies, and suits. Okay, cool. So now how do we let Gemini run a query like this instead of guessing or making up data or telling us that it can't answer the question because it doesn't have access to our data and it's just giving us general market data? We do this by giving it a BigQuery tool. And so now this is going to be agent with a BigQuery tool. Or let's just call this agent with tools. BigQuery tool, and cloud storage policy document retrieval, because we're going to add that later as well. All right, so we've already got the GenAI SDK imported. We need to add 2 more modules here. So we are going to import types specifically, and we're going to import BigQuery, the BigQuery module. And so the BigQuery module is what we installed that a little bit earlier. Now we need to add a BigQuery function, or a function that allows us to access BigQuery, or allows the agent to access BigQuery. So we're going to call this query BigQuery. And I am going to just walk through this quickly again. So the function signature here takes a SQL string and it returns a list. And we are going to walk through this function now. Inside the function, we're just creating a BigQuery client. That's what this line does. Similar to how we created the Gemini client. This line here sends the SQL to BigQuery. The dot result waits for it, and it waits for it to finish and then gives us the rows. And then the return line basically converts each row into a regular Python dictionary so that it is easy to work with in Python. And this is basically just the same thing that we ran in BigQuery console wrapped into a function that we can call from code, but the model can't see this. It doesn't know that the function exists. I need to describe it. I need to tell the model that it exists. So now that's what we are going to do. So I'm just going to copy this code in. Yeah, so all this code, by the way, I have prepared ahead of time with the help of Claude. There's no shame in doing that. A lot of people are using AI these days to help them write their code, and that's it. That is okay as long as you understand what it is doing. So let's go through the BQ_func variable that I just added, and this is a function declaration. So let me walk through it real quick. Here we've got the name of it that has to match the Python function that it corresponds to, which is query underscore BigQuery. We are going to give the agent a description here. That is what this is. This is very important. This tells the model what this tool does, and it lists every table and every column, I believe, that is available to query. This is the model's cheat sheet for writing SQL. It tells us, it tells the model what is actually in the data. So as we're going to learn, this is super important. The better the description is, the better the SQL that the model will write. And you'll come to see that writing or creating smart agents, creating helpful agents often comes down to what you put in these descriptions. Now, we've also got the parameter schema here. This tells the model the function takes one argument called SQL, that argument is a string, and that it is required. Now, we're going to look at the all tools variable here. And what I've done here is I've wrapped it in a tool object. That is what we will hand to the model. And now we're going to update the model call at the bottom to pass the tool in. And then we can see what it generates. So let me change the existing response here. And let me walk through this real quick. So the generate call content now has a config parameter here, right? If you look at this line, that's where I pass our tool to the model, and I changed the question to be specific. So it's October to December 2024 instead of just the last quarter, right? And that'll just help us compare the output from the model to the output from our query earlier. This is the same range that we ran in the BigQuery console. And then down here, let's look at these three lines. When you give the model a tool and it decides to use it, the response doesn't necessarily come back as text, right? It comes back as a function call. And so what this does is it gives us a list of function calls that the model wants to make, and we grab the first one with index 0. And then the next two lines gives us an object with a name property and an args property. And so we're just grabbing each of them. And yeah, the first one is just, the name of the tool. And the second one is the SQL that it plans to run. This is just like the SQL, the text of the SQL that the model is. It hasn't run it yet, but it's preparing to run. So it hasn't called the function yet. I just want to see what the model does, what the model plans to do. And so we're gonna run this now. See what kind of SQL it comes up with. All right, so here we go. So it correctly identified the tool to run, and it identified it came up with this SQL statement. So it looks like it's very similar to what we wrote ourselves, actually. Very similar. The model read the question. It looked at the table schemas. Like it's kind of You have to remember this model did not have access to this query that we ran. It just came up with that on its own from a natural language question that we asked it. What were the top 5 product categories by revenue between October and December 2024? Right. So I did not prepare this ahead of time. I didn't tell it to do this except with the natural language question that we just asked. So it wrote this SQL. It figured out the join. It figured out the date filter and the aggregation, the sort, all from the description. Right. These numbers here are referring to the columns, even though over here we used the column names. And it limited it to the top 5, which is exactly what we wanted. So, but it hasn't run anything yet. I just wanted to see what the SQL query that it was preparing was, but it's asking us to run it. The model doesn't necessarily execute the code. It says, I want to call this function. I want to send it this argument. And we now are going to let it do that, right? So let me close the loop. I need to execute the function, get the real data, and feed it back so that the model can write a human readable answer. So we're going to replace the response block here. And we are going to replace it with a bunch of code, but I'm going to walk through it all. Here we go. All right. Okay, so what did we add? We added everything below here, all right, starting with available functions. Now I'm going to walk through it bit by bit. Available functions is a dictionary that maps function names to the actual Python functions. When the model says call query BigQuery, we look up query BigQuery in this dictionary, right, which just has one item in it right now. And we get back the real Python function to execute. So right now there's only one function registered, but we will add a second one in this tutorial. Down here with this function, what we are doing is we are wrapping everything into a reusable flow. So we're sending the question to the model, the same generate content call as before, and we are passing the tool in. So down here, so this is sending the question to the model. Down here, we're checking if the model wants to call a function. It might not want to call a function. If it doesn't want a tool, maybe the question is something it can answer from general knowledge. And in that case, the function calls is empty, and we just print the text and we stop. Now moving on. If the model does want to call a function, though, we grab it the same way as before. This is something that we're familiar with. I don't need to explain that again. And then down here with the results, we actually execute the function. This is the execution line. This looks up the function name in our dictionary, and it gives us the actual Python function. We unpack the model's arguments as keyword arguments. That's what this is. And then, so if the model said, call query BigQuery with SQL, equals this query, then this line becomes, query BigQuery with the SQL statement as the argument. And then we print the rows that come back, right? Now, for an important part, feeding the result back, I built this history, this list called history. It's got 3 entries here. So the first is the original question. This is types.content with the role equal to user. And essentially this is wrapped as a content object with the role user. This is the original question. And then we've got the model's full response right here. So this is the first item in the candidates list with content as well. And this block down here is the function result wrapped in part.fromFunction response. This tells the model, here's what came back when I ran the function you asked for, and we take that. This gives us an ability to kind of store the history, which we will use later. And I want to point out one last thing in this function. I make one more generate content call with that full history. Contents equals history. And then the model writes a final answer using the real data. And we print the text of that answer. Okay, so let's run it and let's see what happens. Again, we're asking, what are the top 5 product categories by revenue between October and December 2024? Okay, cool. All right, so here we see, yeah, okay, so interesting. Outerwear, jeans, sweaters, fashion, and suits. Outerwear, jeans, sweaters, fashion, and suits. Yeah, so the categories are the same, but this is interesting. The total revenue numbers for these are different. And I believe that is because the query does not exclude canceled and returned orders. Yes, it does not. So we have that in our query here, but we don't have that in the query that the model generated. So it might not have that context. So what we could do is this will actually be a useful kind of teaching moment. Keep in mind that some of the orders should not count toward revenue numbers because they have status canceled. Is it with 1L or 2Ls? I believe it is 2 L's here. It can be either in English. Canceled or returned. Let's see what happens when we update the description. All right. So it's asking the question. And 56121, let's compare that over here. 56379. Okay, so it's still not exactly the same numbers in terms of the numbers, although the categories themselves, which are really what we wanted in the question, are exactly the same. But this leads to a useful and interesting point here. If you need a certain exact, precise result and control over the query in a situation like this, you should probably write it yourself or give very, very detailed instructions in the description, right? And in general, if you needed your revenue data or something like the top products by revenue to be related to some very specific metric or KPI calculated in a very specific way, arguably you would want to just have a dashboard for that, right? But we are imagining that this is an agent where we want people to be able to ask natural language questions to get answers to those questions quickly from one place, serving a vast variety of analytics and business needs, right? So this would be good enough for many cases. We could investigate why this is a little bit different. I don't know exactly why, just looking at it. But I do know that we got the top 5 product categories, that was accurate regardless. But I just want to make this note that, in the real world, you do have to think through how much detail you want to put into the description, and also whether or not this is something that you should just do yourself, right? Okay. Now let's change the question to something vaguer and see what happens. So if we go back to our question that we originally asked, actually, I'm just going to replace this whole line. If we go back to the question that we originally asked before we gave it the BigQuery tool, what are the top 5 product categories by revenue last quarter? Something kind of interesting happens when we do this that I want to demonstrate. So first, before even getting that answer for us, it recognizes that it doesn't know what the last quarter is. It doesn't know what the current date is. It doesn't know what the last quarter in the data is. And so if you look closely down here, what it tried to do is it got the most recent date from our order items table. And it ascertained that the most recent date, the max date, is March 16th, 2026 at 11:48. Okay, I got a little confused for a second because the maximum date, the most recent date in the data set apparently is March 16th, 2026. It's, which is in the future. But this is a synthetic data set, so I'm not really going to question that too much. But anyway, it grabbed the most recent date, and so now it knows that the last quarter means Q4 2025, so October to December 2025, likely. But we will see what it does. And the point here is that what's interesting is that it's actually it's actually giving a response of a function call, right? And what that tells us is that it wants to run a second query, the actual revenue query, using this date. So it recognizes that it does not actually have the answer to our question, and it wants to run another query. But we don't let it do that right now. So our agent needs to take multiple steps. Our code assumed that one step was enough, but it needs to take multiple steps. So let me fix that, okay? So I'm going to replace the ask function with an updated ask function, and we're going to walk through it. The thing that I've added to this function is this while loop, okay? And essentially, it used to be a straight line function. Now, because it's a while loop, it keeps going until it doesn't need to run any more function calls, right? So before I was passing the question directly to generate content. Now I have a history list right here, and I'm building up a conversation and passing the whole conversation each time. So you can see how this allows for multiple function calls if we need them. Inside the loop, this history is sent to the model, and then we immediately append the model's response to the history. History is sent to the model here. We immediately append the model's response to the history. That preserves the thought signature for the next iteration. Down here with the if statement, if there's no function call, we're done. We just have a return. But if there is another function call, we handle the function call as we did before. And everything down here looks pretty similar. Oh, I added an isInstance check because then it handles both lists from BigQuery and strings. We will need that for cloud storage later. And instead of making a final model call, I just append the function result to the history. And that is in history.append right here. So yeah, so this basically, allows the model to decide whether it needs to keep making new function calls. If it needs another function call, it makes one. If it's ready to answer, it answers. The while loop breaks. The loop keeps going until the model responds with text instead of a function call. All right, so given this in the same question, the same vague question, let's see what it outputs this time. All right, so now we see the first query, and now we see the second query. Yes, okay. And this time, so we see Q4 2025 from October 1st to December 31st, 2025. That is exactly what we expected, given that it got it ascertained that the most recent date in the data set was March 16th. And we have outerwear, jeans, sweaters, swim, and fashion. Was that different? Let's see. Outerwear, jeans, sweaters. Yeah, it was different. Interesting. Anyway, and it gives a note here, a natural language note, saying that the calculation excludes orders with the status of canceled or returned. All right, cool. Now, in production, you would want, in reality, a maximum iteration limit on this loop so that the model can't spin forever. You would also want error handling for bad SQL. Maybe we will cover that kind of use case in another video, but for now, this is for dev purposes, experimental purposes, this is enough. Okay, so our loop handled both the first query and the second query, and so now we know that our agent can ask as many questions as it needs, as many function calls as it needs to get a satisfactory answer to the question. All right, cool. Now we're going to create a document in cloud storage and allow it to do something similar with a policy document. So I'm going to run this command in the terminal. This is just going to create a text file, return policy.txt, that looks like this. And this just has our return policies. Standard returns are accepted within 30 days. Items must be unused and in the original packaging, blah, blah, blah. It is going to access this in order to answer questions about the policies. But we're going to put this in cloud storage first, okay? And we're going to do that with a couple of gsutil commands as shown on the screen. First, we are making a bucket, that is the mb command. Next, we are copying the file that we just created to that bucket. Okay, so it's creating the bucket and is copying the file. Now, we can see the bucket if we go to the console and we go down to cloud storage. We can see the bucket that we just created. Yep. So this is the file. And we should be able to open it real quick. Here we go. Yep, so it's the same file that we created. Cool. And now we need to add a cloud storage tool to the agent and not just the BigQuery tool so that it can use both. So we're going to add a function that reads from cloud storage. We're going to add a declaration that describes the function to the model so that it knows what kind of tool it is. And then we're going to add a line to register it. The agent loop itself down here does not need to change at all. We constructed this in a way where it can grab whatever functions, whatever tools it needs. And yeah, available functions is already being passed. And we're just going to add 2 available functions. All right, cool. So we need to import a couple of new things, import OS, and from google.cloud import storage. This is the cloud storage module. Now, below query BigQuery, we're going to add a similar function for cloud storage, takes in a file name, grabs the GCP project from the environment, gets the bucket that follows this naming convention, project-agent-docs. You could have a bunch of different docs in there. Grabs the file and then turns it into text. And so then the agent can actually read it. So when the model says, read return policy.txt, this function goes to that bucket, gets the actual file, and gets the actual text. Okay, now below this function declaration, we need to add another function declaration. We're going to add a docfunc, which basically does the same thing for our cloud storage file, our policy txt file, as we did for our BigQuery declaration. So the name here matches the Python function, and it matches the Python function. And then the description tells the model, read a policy or reference document from cloud storage. And it's got a list of the available documents here so that it knows description of the documents, that knows where to look for these things that are listed here. So again, that is obviously very important, right? And the description can save a lot of time and give the model a lot of guidance about where to look for answers to different questions. And then we've got the parameters here, again, saying that this argument is required. So it's doing the same job as it did for our BigQuery function declaration. It's just for a different data source and different tool. Now we get to update the all tools line to include both declarations. And it's already suggesting that we add docfunc, which is great. And then we get to add read document to the available functions here. So there we go. And we are pretty much all set. All right, so the loop itself is the same, but now we want to take the else branch and we want to change it real quick in the conditional here. So we just want to change that. And the reason we want to do that is we want to get the file name and the length of the document to be printed as well, just so we can see it. But this was already the part that handled the document, and it would have been handled fine even if we didn't add that. But we just want to see that so we can kind of confirm that it's looking at the right file, especially if there were multiple files here. And now we're going to change the ask call at the bottom. So we're going to do two questions, one which we predict to be kind of a BigQuery question, and the other which we predict to be a policy question. And if we run, all right, the display of my terminal got kind of messed up. But if we run this again, Python 3 agent.py, both of the questions will be asked, and we should see, yep, the natural language response to our question. Again, it's interesting. It's a little bit of a different number again, and I think it's asking the same exact question. That is interesting. Again, the categories themselves are the exact same, but the numbers are different. I would be very curious to look into that. And then we've got our answer, which uses the return policy. So our return policy for electronics is as follows. The return window for electronics is 15 days. Items must be unused. Once processed, refunds typically take 5 to 7 business days. Please note that sales, So, and then standard shipping costs are non-refundable. Cool. So you can see how this would be super useful if we have a long policies document, if we have many documents that we want to ask questions from. The agent would be able to discern with appropriate descriptions, and the agent would be able to discern which one to look at. Okay. Now, let's try a little bit of a trickier question. It's not necessarily super tricky, but if we ask this question, a customer bought something 20 days ago and wants to return it, can they return it? You might think an agent not properly configured might think that this is a data question, or that they should look in the, they should try to look for the order in BigQuery, right? Also, it doesn't necessarily know what kind of item it is, what kind of order it is. So, knowing to look in the right place and also responding with the right amount of certainty is kind of what we're testing here. Generally, yes, you can return it. Our standard return policy allows for returns within 30 days. However, there are a few exceptions to keep in mind. Electronics must be returned within 15 days. Yeah, so it figured this out. It appropriately read the document and responded with a measure of with a measured response. If your item is a standard product, then you are still within the return window, but electronics must be returned within 15 days. So it gave the appropriate information, even though it didn't know for sure, whether this person could return it. So now, this is a script that I'm running from the terminal, but I want to just show you what this could look like in the browser. And we're not going to deploy this in production, but we're going to deploy it locally, and we are going to, just, check out what it could look like and imagine it being kind of deployed as an internal tool, in our company. So I'm going to install Flask. This is something that I actually already have installed again because I did this already, but you might not have installed, so it might take a second. And we're going to add a function to agent.py. Okay. Where actually, let's add it up here. Essentially, instead of printing the result, we're going to return the result. And I'm going to get rid of this so that this doesn't run anymore when we run the file. So it is, it is returning the result instead of printing it. Now we're going to create a new file called server.py. This is going to be our Flask app. And we're going to wrap the agent in a Flask service. You don't need to know all of this code, especially because a lot of it is HTML and JavaScript. But what we're doing here is we're importing Flask requests JSONified to handle JSONs in a convenient way. And then we are importing the function that we just created in agent, the agent file. And down here, this is a route that is a post endpoint. It reads JSON from the request. It pulls out, that's what this is. It pulls out the question. Down here, it passes the question to our agent's ask and return function. And then it sends the answer back as a JSON. So that is what the browser will call when you hit the ask button. And then down here is the HTML and JavaScript that makes it look nice and will actually grab the text input. Okay. The root here is the actual home page. And then down here at the bottom, we've got our port, which is going to be opened up, and we are going to access the app on that port as well. Cloud Shell allows us to do local web previews of apps that we run. So I'm going to run Python 3 server.py. Cool. So now it's deployed. I can open this on the port that we opened. And so now we can ask questions in this interface instead of in the terminal. So we could click any of these, or we could ask our own question. Let's ask, for example, what were the top 4 brands by revenue in 2024? Oh, okay. Unexpected token. Okay, so we actually got an error here. And when we look at I think this is, again, a teaching moment. When we look at the error message down here, essentially, it's an auth issue. The Cloud Shell compute credentials are stale or misconfigured, so we need to refresh them. I'm going to do that by typing in gcloud auth application default login. Yes. All right, so now we should be all good. I'm going to run the server again. And we should be able to refresh this and ask our question again. What were the top 4 brands, for selling brands of 2024? Cool. True Religion, Calvin Klein, Diesel, Carhartt. Interesting. And again, we get this note, excluding canceled and returned orders. Again, in natural question. So that's pretty cool. So we've got the same agent that we were interacting with through the terminal running as a web service. We typed our question in the browser. It hit a Flask endpoint. The agent wrote SQL, queried BigQuery, sent back a real answer. We could also ask, I have an electronics item that I bought 10 days ago. Can I return it? And can I not pay for shipping? Can I be refunded for shipping? Yes, you can return your electronics item. Regarding shipping costs, according to our policy, shipping costs are non-refundable. Please ensure the item is unused. Yeah. So you can imagine how this is really useful if you have lots of people asking questions about your data, lots of people in your company asking questions about your data that require answers from your data or from policy documents or other internal documents. They could get those answers from an assistant, an agent with intelligently described and configured tools, right? We just did 2, but you could imagine there being many. And I think it's important to take a step back and talk about what we built and what we didn't build, because those are kind of the real takeaways here. It's easy to kind of look at this and be like, oh, well, we just wrote code, and how is this different from if I wrote code like a year ago or 2 years ago? Think about what we didn't build. We didn't build a SQL generator. What we did was we described some tables and the model wrote SQL on its own. We didn't build a document search engine. The model read a file and pulled out the relevant section based on our natural language query. And we didn't build a router that looks at keywords and decides which backend to call. We didn't build that logic. The model figured out whether a question was about data or about our policy document. And so every one of those normally would be a separate system that a team would spend months on. We got all of them from the same interface. We just describe the tool, we let the model decide when to use it. Now, it's important to, again, understand and note that that requires making sure that we put thought into our descriptions of the tools, as well as into the logic we use to allow our agent to call different functions, essentially different tools, and how many calls we allowed, things like that. So the multi-step thing that we hit, where the model first checked the date range before running the revenue query, that is, one part that a lot of people still don't kind of grasp about agents. It's not just, AI calls this function. It's AI decides that it needs information that it does not have. It goes and it gets that information. It reasons about the result, and then it decides what to do next among the tools and the functions that you have made available to it. We didn't program that logic. We gave it the tools and the descriptions, and it figured out the workflow on its own. So we're operating at another level of abstraction, essentially. That is what this allows us to do. So under the hood, the core of what we built is that loop, right? Send a message to the model, check if it wants to call a function. If yes, then feed the result back. Do that again until it doesn't need any more. And if no, then that is our answer. That's our response. That's the whole agent. Everything else, the function declarations, the history, the thought signatures, all of that supports this loop that we created. Now, it's worth mentioning that Google now has a framework called the Agent Development Kit, the ADK, which you might be familiar with. And it kind of does all of this for you, or at least allows you to do this more easily. With the ADK, you define an agent object, you hand it your functions, it handles the loop, the thought signatures, the session management, the orchestration of multiple steps, everything that we wrote out by hand. It also gives you other things. But I wanted to build this from scratch because now you know what an agent actually is. When you use the ADK now, which we may do lessons on in the future, videos on in the future, or any other framework like LangChain, you'll understand what is happening under the hood. You'll know, why something broke. You'll know what the framework is doing, what it's hiding, or at least you'll have a better intuition about that. So I didn't want to skip this. I wanted to show this. I hope you found that helpful. Now, let's also talk about the limits here, right? The model today wrote good SQL, or at least good enough SQL, but it doesn't always. It won't always do that. It routed to the right tool today, but it won't always do that. You will have these edge cases that you will not realize. And so you could imagine that there's kind of a whole new testing paradigm that we might need with this, right? How do you test agents, right? How do you make sure that it's doing what you want it to? How do you explore the edge cases and try to break it? What we built is genuinely useful, but it's also not perfect or going to be perfect. So knowing where these imperfections would show up and what to do about them, that is the difference between someone who's good at agents and someone who is not. That's the difference between a demo and a production system that you can actually ship to users, even users within your company. And that is potentially what we'll cover in the future. So I hope you found this helpful. I would love feedback. Let me know what you think in the comments. And in the meantime, take care. Thanks so much for your time.